Shailesh Kumar ji, the National Defense Platform. So I will be telling you about the Kaveri derivative engine.
Sir.
So this is a Kaveri derivative engine for unmanned combat air vehicle. This unmanned combat air vehicle is designed around the achieved performance of the Kaveri engine and the envelope. The unmanned combat air vehicle specific technology likes new fan with a variable, because the unmanned combat air vehicle will be having a serpentine air intake, so it should have a distortion tolerant. So the distortion tolerant fan, and this is a autonomous air vehicle. So for autonomous air vehicle, we should have a advanced full authority digital control that has been done, and we have a more reliable with cross-channel data link. We had that thing. Then, being it is a strategic in nature, the fuel control system we have done on our own. So these are the things, specific technologies we made it, and we integrated and we tested the engine at GTRE. We have altitude tested the engine at Central Institute of Aviation Motors, Siam, Moscow, Russia. There on the unmanned combat air vehicle flight test envelope, we have tested the whole thing. Then we have demonstrated the performance and operability of the engine with unrestricted carefree throttle movement, which is very much required. So we have completed the testing, and we have completed 50 azimuth cycles we call, which gives the confidence on the structural integrity of the engine. Then the engine is tested with aircraft mounted accessories like MAC-B, PTO shaft, aircraft mounted hydraulic pumps, heat exchangers, then JFS. It will be starting with a jet fuel starter. All how the engine is integrated in the aircraft, we have done the testing. That is called the installed performance, and we could able to prove to our ADE all the performance is doing very well. So this is regarding the Kaveri derivative engine. This is the Kaveri engine model. This is a twin spool door bypass ratio afterburner engine. This is the fan. This hyper compressor, combustion chamber, turbine. So this will be generating the gases. After the gases, it will be converging and diverging nozzle will be there. It will be expanding. So it will be producing the thrust from the nozzle. This is the small turbofan engine. DRDO designed, developed, qualified, and recently we had a successful flight testing of this small turbofan engine in Indigenous technology cruise missile, which meeting all the requirements of the mission like sea skimming and terminal pop-up.
Jai Hind friends, this is one of the proudest moments for India to have the 4th generation plus aircraft developed, homegrown in India, the LCA Tejas, the light combat aircraft Tejas. DRDO has taken a lot of pains, different labs have worked for that, and we have come to a stage that LCA Tejas has been flying since very long, and it has shown globally in some air shows, and it has performed very well. It has enthralled the audience very well, and there are weapon systems, different weapon systems that can be integrated in our own indigenous LCA Tejas. That is the beauty of this aircraft, the fighter aircraft. A country which could not even produce a needle at the time of independence has developed technology of that level. So the LCA Tejas was developed because of the vision, because of the hard work of our scientists, because of the technology we have developed on our own with the collaboration of public and the private partners. The private industry has also contributed to this project. The only thing is required is the indigenous engine, or maybe an engine which is produced back here in India. This should be our own engine. We should have the capability to produce in mass numbers. Then only we will be able to fight with the enemy, and we can speak from the position of strength. that we have such robust systems. So for mass production, engine dependence should be done away with. How can it be done away with? To get an insight about the development of aero engine, various aspects of aero engine, I am being joined by Dr. S.V. Ramana Murty from Gas Turbine Research Establishment, a lab of DRDO, a very prominent lab of DRDO, and I am very privileged, honored to have Dr. Murty sir. Sir, welcome to National Defense.
Thank you.
Sir, the first question, where we are at the moment with regards to this engine, aero engine?
Yeah, thank you. Just I want to tell, what about the engine development? First, I will start with the Kaveri engine. That is the flagship project for our Gas Turbine Research Establishment. As of now, we have developed 4 core engines we call compressor, combustor and turbine, and 9 full engines. Total 13 engines have been built, and we are tested for more than 3,400 hours, which includes GTRE test bed running, which includes altitude testing at Siam, Russia, 180 hours, and flying test bed trials 57 hours on IL-76 at Russia. So altitude testing means we will be simulating the flying conditions, that is the altitude and forward Mach number, and see what is the engine performance. So we could able to complete that thing, and we could able to achieve 49 kilonewton thrust instead of design intent of 52 kilonewton. There is a shortfall of 5 in dry mode, percentage wise 5%. Then we have completed all component safety and reliability life related tests. So we have completed more or less.
So at the moment, what is the thrust weight ratio?
Yeah, now the Kaveri engine thrust to weight ratio is what we achieved is around 6.5. It's supposed to be 8.
So we are lagging behind in achieving that thrust to weight ratio, and that would be done in future. But what is the vision to achieve that thrust weight ratio, because that is what Air Force would want for the LCA?
Yeah, we are taking all the steps to improve the thrust to weight ratio, that is through technology development projects, through GTRE, Indian industry, R&D labs, CSIR labs, our sister labs, and Indian industry also. For example, we want to improve the thrust to weight ratio. We call turbine entry temperature should be higher. The turbine entry temperature will be in the order of 2000 Kelvin. Actually, that will be the temperature a hydrocarbon fuel when you burnt, it will be maximum of 2200 Kelvin or 2300 Kelvin. So we have to cool the blades, otherwise they will melt away. So that is called single crystals castings we should have. So we are developing with our sister laboratory DMRL, developing the single crystal casting technology there, a second generation, third generation, fourth generation, so that the turbine entry temperature can be increased, so that you can increase the thrust to weight ratio. That is one. Second thing is how to reduce the weight design wise itself. For example, we are going for the blisk. Generally the blades will be assembled to the disc, and there is a retaining plates, or they will be bolted. It will be cause for a higher weight, higher losses. Whereas the bladed disc means it is a single component. Say 73 blades are there, one disc is there, that will be only single component. 25% of the weight can come down by using the blisk for the blade plus the disc, whatever the weight if you take. And the reliability also will increase because it is only one part now. So that is regarding the blisk technology. And for turbine side, we call a boltless blade retaining arrangement. There won't be any bolts. Like simplified way, if you want to tell, you know the cooker, everybody knows.
One piece.
Yeah. Now you know the cooker. There won't be any bolts. You will be taking out, keep that thing, circumferentially lock it, it cannot come out, yes, whatever the pressure. So very simplified way I am telling, but we are going ahead with a boltless blade retaining arrangement so that a lot of weight can be saved. Then very, very important is one latest trends in the technologies is powder metallurgy discs. See, the disc is the, well, there is a disc, HP turbine disc. That is the highest stressed part in the engine. That will be, I mean, you know the science, I mean, all the things.
Yes.
The running stresses will be almost above the yield point, near to the plastic range actually. So, normal alloys, that means to put two metals or non-metals, no, it cannot withstand to the temperatures. So, some high refractory elements, small fractions you can add up so that you can get a better strength discs. But that has to be sintered actually. That is called powder metallurgy disc. We are working with our sister laboratory DMRL. For example,
Powder metallurgy disc would mean that refractory material, what could be that? Is that available in our country?
yeah, very good question. I will come later than I go to that things. See, as in India, we don't have all the minerals like a zirconium, like a rhenium, like a ruthenium. This is called as a rare earth materials that we don't have, like a China or Africa, South Africa. People are there, but we suggested we can have a bank metals. Right now, China is doing that thing. They are procuring a lot of metals, whichever required for the next 10, 15 years, like a bank, metal banks you keep it,
Yes.
so that we can use for that thing. So, coming to your question, all the minerals or metals, I mean, in our India is not there. So, we have a strategy how to get that things and keep that thing.
But that is also a factor in delaying the engine development?
Yes, all the materials are the super alloys we call, most of the things. Just now I said like a single crystal we called CMSX4. Now we started developing, but that will be getting from outside. The procurement time, then you know the geopolitical situations. Okay, getting a material, I mean, now of course we started with Midhani, PTC now they started, and Sunflag. Lot of people there started in India. Now we have started, they will be coming, and our HL F&F, they made the all the forgings indigenous for a few. Since you asked me, the disc whatever I was telling is required a 50,000 ton forge press.
50,000
ton. So that type of, I mean, is not there in India. Only we have to get, I mean, imported from outside.
But HL has taken the task.
Now, yes,
They are-
exactly. Oh,
they are
very
doing
good. They started now as a national facility. See, that will be used for DRDO, HL, ISRO, then even NGOC, then BHL. Wherever the large size discs are required, that is required. But if you take the Indian scenario, I mean, all together requirement they can do within 1 month. So if you are looking from what is the return of investment, it cannot be. But we can be a part of the global supply chain.
So this is one part of it. There were two other factors which are delaying the engine development. So how can we overcome those two factors, sir?
Yeah. Now we should have always the technology development. Get the technology readiness level up to say 6. Then go for a mission mode project so that we can get that thing. That is indigenous technology development. Now what we are proposing is like a 5th generation fighter aircraft which is having a thrust to weight ratio of the engine 10. What I said 6.45, what we achieved to 10.
5% difference.
Yeah. So 6.5 to 10. So almost like almost like 40%.
Yeah, almost 40%.
Almost like 40%. So if we want to achieve that thing, we are proposing co-design, co-develop with a international engine house. See, the military or civil engines, only 4 countries are designed, manufactured, certified, and they are flying.
US, Russia, Ukraine,
Russia,
and China. No,
China, they are not
China,
yet
they
come.
have acquired the company.
Yeah, they are not yet come. USA, that is the 2 are there. One is, I mean, fighter aircrafts I am talking, GE Aviation and Pratt & Whitney. If you take UK, there is a Rolls-Royce. You take France, that is Safran aircraft engines.
Okay.
And Russia, I mean, where we are getting L31FP, RD33. These are the 4 basic things. Ukraine and all small engines.
Okay.
Okay.
But whatever our requirement, these 4 countries, they produce to that level.
Yes, exactly. So we should do co-design, co-development is one of the engine house, international engine house, so that we can acquire the know-how and know-why. Now we are in a position, we have developed already the technologies, we are in par with them, so that together we can do that thing. Later, once we have the technology blocks with us, any variants or further new engines we can develop on our own. Any variants also, like a civil. See, market should be more. Here, the investments are so huge. If you are looking from the return of investment, only military cannot be. So if you are going for a spin-offs like civil or marine, so benefit will be huge actually.
So these are the 4 big countries where we have the technology. We may explore some joint ventures. So what are our endeavors till now? Have we approached these 4 countries? What was their reaction? Are they ready to collaborate? And collaboration would mean the transfer of technology, like we had what we see in the BrahMos.
Yeah, I mean, we are in touch with collaboration with the international engine houses, and we are looking for design and know-how and know-why. That means we will be having the complete thing. For example, a material data. See, nowadays we are going with a damage tolerant design. Lot of advanced materials, high strength, high specific strength we call. Low weight, strength will be very high. So that material data, some of the things we don't have. Then the design methodologies we have, but for the thrust to weight ratio of 10. So we want a total transfer of technology. That is know-how, know-why. Know-how means how to manufacture. Know-why means how to design on our own later also. So that's what we are looking from them.
Wonderful. So in a way, this is a feasible option where we can have the joint venture.
Yes.
And what is required from the government side, because you are doing the efforts, who should take this initiative and who should lead the initiative? Because ultimately you are the person who is heading this. I should know from your the whole viewpoint, and the government should take a decision accordingly thereafter.
Thank you very much for that question. Very lighter way only I will tell. So far for Kaveri engine, we have spent $250 million. A engine of this order, a 5th generation engine, it requires $2.5 billion.
So for a pity we want the Aero engine for LCA Tejas, that's not possible. But we are ready to pay $2.5 billion for acquiring the aircraft. If we develop the engine here, perhaps we would be exporting and we will be earning this potential in just few years. And moreover, we will be saving the money, and we will having the technology where we can produce at a massive level, 100, 200, 500, whatever we want the aircraft numbers, like the China is doing. Is it, sir?
It's true. Say once the design and development is over, the requirements will be huge. So once we are going the requirement, so that the 2.5 billion and plus production, it may not be, it will be getting that thing. So one is money, investment. Second thing I will bring it to you, since you asked me why you are taking long time. Just I will give you the Kaveri scenario, just to understand ourselves. There is a developmental problems. Every engine house faced that thing. For example, I will tell you, I'm a turbine designer. A LP turbine blade resonance was there. We have redesigned. Manufacturing, the investment castings, it has to come from the abroad. They took time, so we got it. Is then tested not only in GTRE, we have to test in the altitude testing. Getting the slot for the altitude testing itself is an issue. Then we have to go the flying test bed.
You have to travel all the way to Russia.
Yeah. So
here you can go anytime, anywhere, you can just test.
All engine houses, they are having their altitude test facility. Whenever there is an issue, they will go back and test. That gives the confidence for any designer. So establishing altitude testing and component test facilities. Say for example, what I said turbine, at the actual condition, it will be developing almost like 35 megawatt. Can you imagine? Okay, so that has to be tested. So high temperature air with that absorbing power we call dynamometer should be available. So altitude testing, flying test bed and component testing is a must. As I said, the materials, manufacturing ecosystem and the huge infrastructure for the, as I said, 50,000 ton hydraulic press. We call, to go to high temperature now, we use some special coatings that we call electron beam physical vapor deposited thermal barrier coating. Those requires investment. So we are going with the government already proposing to establish material, manufacturing, altitude testing, FTB all together.
So this would require an investment of $2.5 billion, and you believe that, sir, there would be countries who are ready to part with this technology, they are ready to give you the test facilities, or we need to integrate here. How it's going to happen? So that our people, the common man can understand, the government can understand, the stakeholders can understand.
Yeah, we are able, we are having continuous discussions with our officials, what we are, planning. Yes, we will be, who are all partnering, together we will be doing, but to start with some testing we will be doing there. But before that itself, parallelly, we are proposing to establish our own facility. Once it is there, we will be doing on our own. And the engine has to be manufactured fully in India. Not only manufacturing, tomorrow we have to have the MRO also here only. So we are proposing to, it is like a national mission we will be doing. Design, development with GTRE, DRDO, with other CSR labs, say like NAL, all other labs. Then manufacturing with Indian ecosystem. Indian industry partner will be there. They will be manufacturing like a modules. One of them will be, yes, like a lead integrator. And if once the certification is over, IAF, the user, can directly place the order on the, like a DCPP model we call, or on the Indian industry partner.
Okay, they can directly place that we need this 100 or 200 or maybe 50, whatever the number is.
Yes, and we will be with them hand holding. Technology will be, manufacturing technology will be transferred from both the sides.
So as I understand, the first stage where we have the technology development, how much time frame do you believe that it is required to have our own in-house indigenous technology development here in India, and then we can go ahead with the production line and other time frame? But what is the time frame for you, sir?
Yeah.
If government essentials that.
Yeah. See, as I said, we are already talking with the Indian industry, international engine houses. Typically, it takes 10 years. See, one design we call aerothermostructural design. That is, it takes 1.5 years, 18 months. From there, one detailed design will be starting. From there, the basic thing will be, as I said, single crystal castings and machining. That development of the single crystal process, getting the castings, then machine, a lot of things will be there. A small tiny holes will be there that has to be laser drilled, and that will be a hollow blade. One ceramic core will be there. Once you take it out the core, you have to vacuum brazing has to be done. So then, as I said, EBPVD, TBC, then the blade will be like a broaching, factory cutting, lot of machining will be there. As together, start from the casting to the machining, it may take 2 to 2 years minimum, 2.5 years. Then we have to test those things. Integrate. As I said beginning, 1 HP compressor, combustor, turbine we call a core engine, that we will test. If any Dyson iterations, we will do that thing. Then we will go for the full engine, GTRE test bed, then go to altitude testing, then go to FTB. These are all here. Parallelly, we will be doing the route to certification document will be there. So, what are the safety margins, what are the life related, what is the reliability testing we have to do. So, it takes all together say 7 to 8 years. Then you integrate to the designate flying test bed also will be over. Then almost 1.5 to 2 years flying in the designated aircraft. So it takes almost like 10 years.
10 years in total. So that's a huge time, but it's a huge investment of time, money, and energy. But it is a requirement which makes our country a potent country, because if we want Viksit Bharat, that would mean that we have to have our own homegrown engine, which we can produce in mass number. But this 10-year investment with the money and everything would be able to produce engine for only for the LCA Tejas, or can it be used for AMCA or subsequent generations? 110
110
for the AMCA.
for the AMCA.
Yeah.
See,
65 is for the LCA.
LCA is 85 kilonewton.
85. So in 10 years, can it be done for AMCA
Yeah.
also?
What I said is, once we get the technology blocks can be adopted from 85 to 120 kilonewton, even higher that things. It can be done. That's where we are going ahead also.
Wonderful. At the moment, what would be the timeline for the production line? Suppose if 10 years is being given, again there would be manufacturing. Suppose if we have a production line, how many engines can be produced in a year? Because then only we can have that, we should have one production line or maybe more. So what is the time frame and the guideline for that, sir?
Very good questions. Your preparation is very, very good.
Sir.
So I will bring out. See, the manufacturing, when we testing the engine, so development itself we will be manufacturing through Indian industry partner. So he's already having the experience, so that the same thing will be going for the production also. So we will be having, say, 20 modules. We will be going through Indian industry partners. So one will be the lead system integrator. As I said, they will be keeping only. So by that time, infrastructure is available. Once the user, place the order on them, they can, coming point to your question, say to start with 12 to 16 engines per year. Later it can go to 24, even further based on the scale up, the requirements of the engines.
But we can always scale up.
Yes.
We will have the capability.
Yes. Let me tell you, today Indian ecosystem is vibrant. There is no doubt at all compared to some time back. And we have worked with Indian ecosystem that who worked with us, proud to say they are part of the global supply chain now. Sometimes we won't, we'll be going to them, they will say, I'm busy with Pratt & Whitney, I'm busy with GE, I'm busy with Rolls-Royce.
Since so many people would be watching this video who are stakeholders, who are decision makers, policy decision makers, I would like to know, because then they would be asking that the warfare is going to the 6th generation, and some countries are already preparing for the 7th generation warfare, almost in space. If we develop this engine, how we move ahead? What would be the requirement for developing 6th generation aircraft engine? Do we have some scale-up plan which goes in line with that, or we need to start from something else from the very beginning, sir?
Yeah, we invest always in the technologies. 5th generation already, I mentioned, we have started like single crystal with EBP-VD, powder metallurgy discs, PMC bypass duct, CMCs, then damage tolerance design. Already we initiated for the 5th generation. Similarly, 6th generation, the thrust to weight ratio is 14. Okay, so there the single crystal blades will be replaced with the ceramic matrix composites. So already we started working with, say for example, NAL. So the technology developments, that is more electric engines will be coming. So all with DRDO, industry, academia, center of excellences, and our sister labs, then with CSR labs, already we initiated. Already we are doing for the 5th generation, 6th generation already we initiated.
So that means if we invest in this engine program, we'll definitely scale up and we can go ahead with further development of technologies. That's very nice. My point of view is like, suppose if I'm an Indian thinking about my DRDO, my Air Force, they should have the engine, they should have our own aircraft, but that would also require own Indian manpower. uh, who can be absorbed. So there would be very institutions which will be churning out those sort of brains from their institutions. But that brain that goes to abroad. So what I mean to say that if we need to develop that sort of technology and we want to retain and we want to graduate to next level, definitely we would need the brain. So what is your vision? What do you want to say to the government so that they can make policy accordingly and they should make policy so lucrative that our own Indian brain that goes out comes back and join our programs?
See, as an Indian, we should be proud. We are very, very good. Go to any Indian house, most of the people who are working Indians. Most of the people, because I interacted with them. We should be first proud. So we have the brain to do the things without any iota of doubt. Coming, why we are not making? Maybe we may not be paying. I mean, we are discussing with the Indian government what should be the things. So we have to pay par with others.
Certainly, we need to give the level playing field.
Yes.
Because they have invested, they are the brain. Not everyone can be treated equally in this regard. Perhaps this also needs kind of lot of investment research on the part of the government, because they need to know who are the people who would be required not only for engine development, for other various technologies. Who are the youngsters who have that kind of brain? Those should be retained. It is always good to go abroad, learn, work and come back, because ultimately we are Indians and working for other countries and making them great. But today is the time when our Prime Minister sees India as Viksit Bharat by 2047. So in next 20 years, I believe that the Indians need to come back, those who have gone abroad, and those who are in India, they may go back, they may go abroad, they should come back with a vision. So perhaps the government has to strategize and perhaps work in tandem with the organizations like DRDO or other labs, and those youngsters, they should be integrated with those labs from the very beginning. Is it, sir?
It's true. It's true.
Because ultimately this is the brain kind of Dr. Murty that are involved in developing such technologies. What is required, what I learned from this conversation with sir, that we need to have our own technology, we need to have investment for that, and the investment is multifold. Instead of $250 million, we need to have $2.5 billion investment. And that is not a big investment, because if we do a deal for any aircraft, this is just for few aircraft and we procure it, and ultimately we are dependent on those foreign suppliers who take us to task every time. We run after them, and at times when we require, we may not have spare parts, we may not have other things, we not have timely deliveries also. So that investment is also very risky. Instead, if we invest in our own technology development, we will have facilities all back in India in our own control. We can always scale up. Worst case scenario, we can always give away the Indian public's money, the exchequer, that will not go waste. There would always be buyers in case of worst case scenario. So as a business point of view, if I think any industry or any government who is investing, they can always pull back. There could be insurers, there could be companies who would be insuring such projects. So can it be done with the insurance companies also, so that the investors' money, if the government is an investor, perhaps it is good, because ultimately it is for the sake of country. But if the government alone per se is not investing, there are big industry partners. So can those investments be ensured?
Yeah. So I will one by one I will go. One is $2.5 billion, what I am telling sometime back, for 85 kilonewton type of thing. When we are going to 120 kilonewton, it will be higher. That is one. The second question what you asked is, what will happen if you are, Indian government or Indian industry coming to development of the aero engines or aerospace, you will get the returns after 2030, they say in the MRO. Late. So keeping an investment by Indian industry, maybe they're having their own hesitation or thinking. Now they're coming, of course, because the returns will come very late. So this type of things
In R&D, this is the normal phenomena.
everywhere. I mean,
Everywhere. It is not in India.
Everywhere.
And if we develop 6th generation or 7th generation technology, it will be much longer time.
Yes. So, and for the manufacturing, now the ecosystem for the manufacturing is set up by the Indian industry, which is very, very positive, because already they are doing or a part of supply chain from the global supply chain. So that we can take as an advantage. So lots they're working for either GE, Rolls-Royce, Pratt & Whitney, Safran, they're having here now in India. So that will be beneficial for us.
So my last question is about in return on investment. If they invest, would it be used only for production for the Indian Armed Forces, or can we have the export potential of our aero engine? If it happen to develop, by God's grace, it should be done. By God willing, it will be done.
I'm always positive.
Yes, I am.
It is required. It is a need of the hour. See, we have our own LCS. We have our own AMCA will be coming. Without engine, we cannot. So engine has to be there. There is no doubt. So we can put the best efforts and we can get that thing. Otherwise, we are not, technologically independent actually. So this is one of the niche area we should have the engine technology. That is the need of the hour. So two more things I want to add up. So last year we developed a small turbofan engine, and we have successfully flight tested in, we call as a indigenous technology cruise missile. So meeting all the mission requirements, the missile flown at sea skimming, very low altitude above the sea, and terminal pop-up, it has to go home that thing. So meeting all the requirements, indigenous missile, indigenous engine. So we are truly Atmanirbhar in this complex technology for the small engines.
That's very
so
nice.
we can come up to that thing.
So I believe that return will be assured, and it's very handsome return, I believe so, because there is a huge export potential to the foreign friendly countries.
Always, because very few countries, as we discussed.
Just 4 countries they have the technology.
Yeah. So once we have our own engine manufacturing here, we will be competitive with anybody else actually, and our friendly countries, it will be most beneficial. And by Vikasit Bharat, as Honorable Prime Minister is telling, to 2047, we should be aero engine should be, we should export our aero engine.
As a journalist, as a citizen, I would always vouch that this country, our Bharat, our India, our Hindustan, that requires our own engine. We have proven ourselves. LCA Tejas is such a robust platform. It has proven everywhere. Only thing is required, the engine. We are dependent on foreign country, which is a friendly country at the moment. But as we go ahead in terms of time, we do not know who is our friend, we do not know who is our foe. We should have independent, potent power, and we should speak from the position of strength. If we want to say and if we want to be listened, then we should have our own engine. Now has come the time that we should wake up, we should get ready, and we should really push our boundaries, and we should break all glass ceilings. We should work together as a nation, not only the whole of government approach, but as a whole of India approach. Everyone is part of this great mission, and I really pay my gratitude to our scientists, our engineers, our business leaders, industry leaders, that they are into this mission, and because of them our future generations will be secured. We are already secured by and large, but I really pay my gratitude to scientists like so humble scientists with great vision, with great brains. Dr. Murty, so grateful, and I pay my gratitude on behalf of my subscribers, viewers, and my fellow citizens. So grateful, sir.
Yeah, as youngsters are there in your youngsters in yours, one point I'm having for them.
Certainly, sir. My request, please go ahead, sir.
Yeah. So first we should have the positive attitude. Yes, we can deliver. Really, we can deliver. First one is positive. Then passionate. Once we have the passionate time, nothing. We can, the energy levels morning 8 o'clock to evening 8:30, 9 o'clock, we can have the same energy levels. So the passionate
Absolutely
will be
agree.
coming.
I fully agree with you. I'm a media guy and it is my lifeline. So if I get up at 6 or 4 o'clock, if I sleep at 11 or 10 o'clock, the energy level remains same if it is media. So that comes because of the passion, sir.
Passion, nothing else. Sometimes be positive, passionate, results may not be coming. Perseverance. If you are having these 3 P's, we can achieve the things whatever we want. Not only in the aero engine, anywhere else also, and we will achieve with the 3 P's.
God willing, sir, we will achieve. And India will be great once again. Thank you for your time, sir.
Thank
I'm
you.
grateful. Thank you, sir.
Thank you very much.